Greetings, Hacksters! I have a very exciting broadcast today. We have an unboxing, which I love, and it's for a kit that I'm very excited about. I've heard a little bit about this from the Cytron team. Very cool. These are the people who made the Maker Uno, which is a wonderful alternative to the Arduino Uno. I should pick that up, actually. I'll show you that later. It's an Arduino Uno that has little LEDs on each GPIO pin to show you what's going on, and it's got a built-in buzzer and button, so that right out of the box you can start creating with your Arduino without having to hook up anything physically, without having to learn about breadboards or soldering. And why can't I get this open? I'm so impatient. Where's my knife? Anyway, I'm very excited about this kit. And it's designed with teachers in mind. So there's an Indonesian curriculum that it is designed to, oh, my bad, Malaysian curriculum that is designed to fulfill. And, oh, there goes my camera. This is not the smoothest unboxing I've ever done, but it's one of the more exciting ones. So as you're going to see, it takes the MicroBit, which is a microcontroller designed for use in classrooms. Actually, they gave away, as far as I know, they actually fulfilled this, gave away one to each member of one of the British educational classes. And it has a little 5x5 LED grid. You got two buttons here for input. It's got an accelerometer, gyroscope, magnetometer. I think has a temperature sensor as well. Bluetooth low energy, and cool little labels on it and stuff telling you what everything is. Let's get that camera back up so we can show you what's in this package. Dude, there we go. All right. And coming right up, here we go. All right, so this is not much to look at yet, but we're going to get it open. And first, here's the MicroBit. Okay, so as you see along here on the bottom, you've got a number of different inputs. You've got 3 volts in ground. This is actually an output, but you also have 3 GPIO pins. However, you see all these other little ones. This is a key part of how the MicroBit connects to different kits. It slots often into a slot in the kit. And that way it makes connections between not only these 5 large pins, but all these little pins. These are all extra pins. This kit is, this board is designed with the ability to learn, the ability for the owner to grow with it. So you can start out just using these big pins with alligator clips or what have you, and then you can sort of graduate as you get older to using the smaller pins and having more functionality. Similarly, it works with Microsoft's online MakeCode programming interface, which starts out in a drag and drop interface like Scratch, but then you can toggle back and forth between that drag and drop programming interface and JavaScript, and it'll automatically convert between, assuming that your programming is correctly done. And so it's a great way to start out with, you know, kid-friendly drag and drop programming and graduate to JavaScript, which is an actual language that people use to build websites and stuff and control robots, which I love. So let's get this kit open, because I got to stop talking about this and start showing you some stuff. Let's get this out of the way. That's for later. Ooh! Right out of the box, we've got some beautiful coloring. This thing looks really rad. Very exciting for kids, I imagine. Well, for kids, for grown-ups, whatever. Let's get this open. Oh, yeah. And it's also wrapped in its own little plastic thing. But, oh, no. Come off. Trying to they've packed it very securely, I'll give them that. So if you order it from them, you are bound to get some good packaging. Woo! What's in the box? We've got the EDU bit board, a step-by-step guidebook. They describe this as having 10+1 lessons along with it. That means 10 lessons plus 1 bonus lesson. So not only is that drag and drop interface from Microsoft really easy to use, but this gives you all the basics from the very beginning. And this is incredibly teacher-friendly. As you can see, it's designed for classrooms. Both the board and the box have a space to write your own name. You have game maps and accessories, a USB power and a data cable, 7 Grove cables. That's because it comes with 7 different modules that are attached to the board to start off with, and you snap them off. We'll take a look in a second. 1 servo motor, 1 DC motor, and a fan blade. So I want to read a little bit from what they sent me. Oh, that's so cute. I'll save that. I love getting notes from afar. Yeah, look at this. Look at those happy kids. Let's see if we can get some more altitude on here. Yeah. And actually refocus for you. There we go. Cool. Yeah, EDU bit. Beautiful. Check that out. And I love this little rabbit logo they have that's going bit bit. Let's get you open. So this was created, they have an earlier MicroBit kit, and they were marketing it to teachers, and they did a bunch of research to see what the pain points were, and the EDU bit is what came out of that collaboration. So they've listened to what teachers actually need, and when I looked at the list, it's a bunch of things that I actually want as well from the MicroBit and have been a little bit let down by. So let's get this open. Oh, that's the MakeCode programming interface that you see along here. Block code. Oh, wow. Okay, so they've got this diagram on how to set it up, and a guide to the EDU bit board. Then they give you a link to the MakeCode editor, simulator window, and so, oh, and they actually show you where those things are too. Wow, whole graphical guide, and then a QR code link to the programming resources page. We have this beautiful booklet. Wow, the craftsmanship on this is amazing. Look at the quality on this. This is a whole 120-page booklet full of activities to do with kids and the EDU bit expansion for the MicroBit. It brings you from the very beginning. We're not going to go through all of this, but we are going to check out a couple of the examples. So cool. Ooh, quick tips. I wonder if I love quick tips. Oh yeah, look at this. If you're not using the simulator window, you can click the tab to hide it, so you can have more space for your coding blocks. That's cool. We'll look at this later, because we haven't actually gotten to the programming part yet. Here are some of the game pieces and the game boards that they talked about. You can! I actually came prepared with some pieces of felt in case I felt like we needed to build something, but it looks like it comes with everything that you already need. I don't know what the deal is with this. Little snakes and ladders game. Wow, dang. This is a whole activity kit. And they have discounts on it for right now. EDU bit Twister, so much. Wow. Okay, here we go. Here's the meat of the thing. It comes with a MicroBit pre-installed. Here's your power barrel jack for power. Oh, yes. Let's get some focus on here. Yes. Okay, so MicroBit. Everything is labeled. Power, low battery LED, over voltage LED. Nice. I2C breakouts. We should start with the simpler stuff. Okay. Here are your 7 snappable, offable breakouts for different interfaces. So you've got 2 buttons here. You've got a 3 LED stoplight kind of thing going on. You've got 4 NeoPixel style RGB LEDs. You've got an infrared interface, which allows you to sense if something is there or not. I think they have that hooked up as a binary one, and I'll tell you how I know that in a second. We've got a potentiometer, twisty dial, a sound level meter. I don't think this is an actual microphone. It can't tell what you're saying or whatever, but it will pick up the volume of the sound that's going on. And you have an audio breakout, which not only includes a little buzzer to make audio happen, but it also has an audio out port, tip ring sleeve kind of deal. which is fantastic. So these are all by default connected to the board through these traces. You can see where the board plugs in over here. Here are all the pin connections, and then they get distributed around. But then also you can snap them off and connect them with the Grove cables that are included. I2C cables, like so. So that you can have more flexibility in how you want to build stuff with this. The other cool thing here is that each one of these things has LEDs indicating its status to help you with debugging. So these ones are analog. Your audio level is an analog value. Your potentiometer resistance value is an analog value. Same thing with the audio out, I assume here. And they even label them analog. So you've got a little sort of dial style LED ring here. And then over here you have digital indicators, an LED for each thingy interface, showing whether or not it is active. So you have these 3 ones corresponding, labeled with the pins, corresponding to the red, green, and yellow LEDs down here. Yellow, green, red, ground. They've labeled all the little connections here. So much room to grow with this thing. Like when I was in school, you know, sometimes people grow at different rates, and sometimes you're ahead, sometimes you're behind. This is so self-labeled, self-documented, that kids can jump ahead if they want to. They could hang behind and check out something else more deeply if they wanted to. This is so cool. It's really flexible. And then you have little indicators for the buttons, of course, as well. And then up here, you have spots for 2 DC motors and 3 servos. This is ridiculous. So in other times, I have tried to get the like a robot built with the MicroBit using 2 servos and a 2 servos and an audio out. And each of those things requires PWM. And you can kind of do it, but it's very glitchy. And sometimes you don't have enough current for all that stuff. Your power supply solves that problem. And when it comes to control, the board solves that for you. You can drive up to 2 DC motors plus 3 servos with it with no problem, which is ridiculous. That's really cool. You're no longer hampered by the limitations of the board itself. It's a great board, but every board has trade-offs. Again, you have a spot to put your name on the back, and you can see that it's a collaboration. And this adorable bunny logo. And each one has its own little label showing what it does. Potentiometer bit, infrared bit, sound bit, music bit. So cool. I have all kinds of plans for this. We're going to jump into that a little bit. Oh, look. Update us on your progress. That's very cute. So then we have our 7 Grove cables. We have, this looks like a wheel. Like you'd put it on the DC motor and then you'd have a little wheelie bot. You could have 2 casters or something. Or direct this somehow. Ooh, what if this might actually be for the servo? Not sure what this attachment is meant to connect to. Maybe it's for this. Oh yeah, there we go. Just a little squeezy on there. Cool. Yeah, and in theory, you could have a servo controlling the direction of this as a wheel, and have 2 other little casters. I'm not totally sure this is a wheel. It could be a pulley or whatever. But anyway, that's there. You've got this fan that sticks onto the motor as well. A little friction fit. Doot. A nice hefty little DC motor, by the way. It's got some weight to it. It's not puny. We've got a servo motor with your typical 3-pin power grounded data connection. You've got this combination power and USB programming cable. That's pretty cool. I'm gonna actually use I'm going to use this for power, and I'm going to use a separate programming cable for programming it, just because I already have all my USB ports occupied with other stuff on my USB-A hub. So, but yeah, power in here. Let's see, where can we get power from? And you could easily use another one. Oh, it's long enough to get all the way from my USB power supply down there up to here. Wonderful. Wow, this is so great. And of course, in a classroom or workshop environment, you always have this problem where wiring and getting power to everyone is a huge pain. And so being able to have a long cable where you can have one power strip up, in the middle of the table, and then everyone can reach from there, that's so good. You have a little screwdriver. Do we have? Oh yeah, for the screw terminals here. Cool. They really put everything in this kit. Now let's take a look at the website. So Cytron's website shows the discount that is available. That's pretty cool. The first batch was 50% off. The second batch was 40% off. The third batch now is 30% off. That's pretty amazing. Each batch is 50 sets, so jump on it now if you want it. Huh? So cool. It is $38.33 USD. That, honestly, for what you get, I think the MicroBit itself typically goes for like $15. And so getting all of this extra stuff, plus all the activities, and this beautiful design is really good. We have... Sorry, one moment. I'm getting some notifications in, and I need to kill them. There we go. Okay, so here you see the Microsoft MakeCode editor in a little window animation, but we can go there ourselves. It's makecode.microbit.org. We're going to open up a new project and do Cytron 1, or EDU bit 1. And we'll jump to that in a second. But as you can see, it's a drag and drop programming interface. Here is a list of the 10+1 hands-on coding lessons. We've got 10 regular ones, starting with Hello World, doing the LED matrix display on the MicroBit, rock, paper, scissors with the buttons, win, lose, or draw with the traffic light bit. The infrared bit basically tells you if there's something there or not. It's not like a distance sensor like you sometimes get with infrared. It's really just an is something there. We've got the potentiometer bit, which controls the speed of the game. And then the bonus chapter is Simon Says with LEDs. It's a bonus chapter because it uses radio communication to hook up two microbits together. So cool. At the end of the chapter, each chapter, there's a challenge which requires you to apply what you've learned to build a useful application for your classroom. Oh, so right away it lights up and plays a melody with the press of a button. Let's check that out. But there's so much cool stuff. There's this animation of breaking the thing apart, which looks really satisfying. I'm going to wait on it, though. Yeah, and go check out the link in the description below if you want to find this page. I want to note that we have talked about a couple of other kits before. There is the KittenBot robot kit, and then also the Servo light board, both of which make pretty good robots. This one is very much purpose-specific. The KittenBot is designed to break out a gajillion servos or other PWM devices from one microbit. And then the Servo light board is a very compact board, which I love, which also is designed to make it easy to connect servos and other PWM devices to the microbit, as well as a little on-off switch, which is always nice, and 5 RGB LEDs. There's one more thing here that I'd like to read to you from an email that they sent. The problems that are solved by this kit. It says, albeit this kit being the most affordable solution, their previous iteration of this kit, the Quick Start Kit, to sufficiently fulfill all the Malaysian KSSR syllabus requirements, it has its limitations. From our research and feedback we gathered from practitioners, we compiled the following pain points and designed the EDU bit kit to overcome these shortcomings. So these are common pain points working with the microbit and the previous kit that they released, as well as for me, just as a creator, just issues that you come across with it. So for example, if you're working with alligator clips, the microbit is designed, as I said before, with these large clippable areas. You can stick alligator clips on there. I've found that not only do these tend to be a little bit wonky, like it's hard to make sure that it's coming out straight and not shorting out to any other connections, but also, as they say here, the protective insulation on the alligator clips is slippery and keeps sliding off of the clips. Wiring is messy. When you have a battery pack, it's difficult to unplug it from the MicroBit. This is one of my pet peeves. These little JST connectors are great for attaching battery packs. However, they are hell on your fingernails. It's just painful, and I always break something, and it's just hard. And you can't pull on the cables themselves, which would be a more easy and ergonomic way to do it, because then of course you risk ripping the cables out of the connector in totality, and that's not good either. So they solved that problem, which is amazing, with the barrel jack connector. It's so much more sturdy. They also say the battery connector breaks if pulled by force. Yeah. When you're working with a buzzer, the buzzer wires break easily. That's very true, and the volume is rather soft, those little piezo buzzers. Also, the MicroBit does not provide sufficient current to power up motors properly. It cannot play music and rotate servo motors simultaneously, as I found before. Yeah, so beautiful. They also have an online resource hub for this, which I think you find if you scroll down. Here we go, sample code and extra resources. The EDU Bit Resource Hub. Explore STEM and coding with EDU Bit. You can actually go check out these chapters already. Super cool. Finally, we also have a MicroBit Basics for Teachers series linked below. So that's the third YouTube link in the description. Go check that out. So let's get this hooked up and running. My favorite part. Can switch my camera here. Get rid of this. Okay, so first thing I'm going to do is plug it in and power it on. Actually, the first thing I'm going to do is adjust my focus. There we go. Now we can see what we're doing. And I'm going to plug it in. Do I need to do anything else? Do I need? Oh, yes. Ho ha ha ha! Wonderful. Cool. We have a few questions before I move on here. Arijit says, the best board for electro noobs is the MicroBit. I definitely think there's a few good contenders. I think Adafruit's, oh my goodness, it's sound responding right now. Haha, whoop, whoop. Cool. Anyway, Adafruit's Circuit Playground Express is also really good for beginners, but I agree, this one is very good. Oh, we got people from all over. This is so cool. Everyone's saying hi. I love it. Pat says, does the board require an external clock? It does not. It does everything on its own. Grooves are truly great. It is true. And one more thing. What's the total price, by the way? As I mentioned, that is about $38 USD. We have, how many total Grove sensors are there? Counting sensors and actuators, we have 7. Then there's also this I2C breakout that has another Grove connector up here. So that's 2 more I2C breakouts available with just jumper wires, and then 1 more with Grove connectors. You can already see these little analog meters going. Ooh, doot. Yeah, and you can see the audio one going there, and the little button one's flashing. Oh, haha, cool. And this is sort of faded. Interesting. I'm curious to see how that one goes. We've got a little potentiometer here. That's not doing anything. This is presumably, I would guess that this is to adjust the sensitivity of the infrared thingy. I don't know. We'll have to figure it out. Cool. So it already comes hooked up with a bunch of stuff going on. Let's see what happens if I plug in the DC motor. We've got these already stripped ends and our little screwdriver. Motors do not really have power and ground wires, a DC motor rather. In general, if you feed power and ground one way, then it turns in one direction. And if you feed power and ground the other way, then it turns in the opposite direction. So I don't really have to worry about which way I hook this up. I just want to see if it's doing anything. So I'm going to plug it into the motor 1 slot. I hope these wires are stripped enough. In fact, let's strip them a little bit more. Here we go. Trying to be really careful with these. I'm not sure quite what gauge they are. There we go. Put that in there in case it starts spinning wildly. You never know. Tighten down the first wire. Oh, nope. You always got to yank them and make sure that they're in there a little bit. There we go. How's that? Yeah. Okay. I have to put the wires in above the little plate. When I turn this screw, it moves a little plate inside here up and down. And what I'm trying to do is crimp the wire between that plate and the top of the terminal. And I have successfully done that with both of these. Nothing is happening, so I guess there's not much. Although there are these 2 little buttons for each motor. Oh, cool! And that feeds its power in each direction. Cool! That's great. So this has a ton of feedback, including little, those feedback LEDs I told you about, but also this little debug device that lets you know if your motor is plugged in correctly. Let's get those wires out of the way. And so I can push it one way and the other way. That is so cool. Very good for the summer months. All right, so let's move on to some programming. And I'm just going to try out the first one of their activities here. As you can see, though, they have a ton of different activities for you. They've got this twister game that you do with your fingers. They've got snakes and ladders, as I mentioned. You've got this twister wheel for that previous game. These little guys that can move around the board. My guess is that this hooks up to a servo somehow. And this clearly has some kind of a servo integration as well. Oh, I bet that's a goalie. Yeah, this must be like a little football goal or something. And then maybe this guy is supposed to block a ball or something. Let's pull up I actually have to share my screen. Oh, I closed it. No! Bring it back. MakeCode.microbit.org. There we go. Okay. All right. EDU bit 1. What are we going to have to do here? Let's find out. So in the first example, it is our Hello World project. So we click our new project button, we type in the project name, and we hit create. Then we say, we'll see this Microsoft MakeCode editor page, which allows you to easily program your EDU bit using the drag and drop method. They have another little diagram of how that whole interface looks, including the simulator here, your programming blocks area, the available blocks that you can choose, and also you can choose to program in blocks, JavaScript, or Python. Oh, a Python. Is that new? Or have I just been oblivious? JavaScript. But then there's a little drop-down menu. You can do Python too. That's so cool. Oh my goodness. JavaScript and Python are both really useful for programming robots at this point. And the fact that you can easily toggle between block code and JavaScript and Python is incredible. So you can go straight from 0 to using real languages that grown-up programmers use in real-world applications. This is so cool. Of course, that's Microsoft MakeCode's thing. Yeah. So here we are on a MakeCode site. Gotta pull it up. There we go. Okay, so the first thing we're gonna do is click basic, the basic block type, and we're going to choose the show string block. And they have little graphical indicators for everything. I'm going to drop it into the start block here. And yeah. Connect the USB cable to your computer and EDU bit as shown. I'm actually going to use my own USB cable for my own convoluted wiring reasons. If you're not trying to run a microphone and a camera and a lamp and everything off your computer at the same time, then you don't have to do all this. I wonder if they have this this example hex file available for download as well, because that shows all the functionality in one place. And honestly, I like to sort of reverse engineer applications from existing known good code. And I think a lot of us like to do that in professional spheres as well as while learning stuff. Like that's a huge way that I learn stuff is by looking at, something similar to what I want to do and then just tweaking it, right? And so I think it'd be really cool if they offered this example that shows all of the things working at once. If they offered that as I wonder if the servo is connected up to this potentiometer out of the box. I want to try that before I reprogram it, because I don't know if I can get this sketch back. All right. So we're going to do that real quick. We're going to break out this servo here. Here's a servo. I'm going to plug it in. And so 1 is at the bottom. S, plus and minus. Presumably that's signal, positive and negative. The brown wire on these little guys is going to be the ground one. The orange one is going to be signal. And I'm going to put on one of these servo horns so that we can see which way it's pointing. I'm not sure which way it will be pointing out of the box. We will find out. No, that does not control the servo. Okay. Well, it's a good try. Wait, it does control the brightness of the LEDs. Hey, look at this. You probably already noticed this, but I was looking at a bunch of screens and stuff. It controls the brightness of the neopixels. Look at that. Haha. That's so good. I wonder if the infrared LED has anything to do with this. It doesn't. Okay. None of these seem to be controlling the servo out of the box. That's fine. Cool. Oh, apparently it's out of stock on the Cytron site, says my friend Fergus. Oh no! Sorry to mislead you, but you got to keep an eye on it for when it is available again. So let's take a look back at the online programming interface. As I said, it says show string hello, and they tell you how to download it. You click the download button at the bottom of the page. I'm going to make that a little bit shorter so that you can actually see it. Hopefully. It's this big purple button, and there's the name of your sketch right next to it. So I'm going to hit download. It's going to give me a hex file. I'm going to save that to my computer. And as the directions here show, I have the MicroBit connected to my computer with a USB cable, and it's showing up as a USB flash device. Yes, it is. Fantastic. And all I'm going to do is drag and drop that .hex file onto the MicroBit flash device, and it should update. So let's take a look and make sure it's actually doing that. Do we have positive function? Oh, yes, there we go. It says hello. So that's our hello world. There's some more cool stuff that we can do. Since I'm on Mac, it always gets mad at me when the MicroBit automatically resets itself. When you drag the .hex file onto it, it programs it automatically and it reboots the MicroBit. And then my Mac is like, why did you unplug this without ejecting it? And that's just a normal thing with MicroBit and Mac. Don't worry about it. Let's see about a servo. control thingy. Let's see. In this booklet, they have next to each one which bits it uses. So I'm just going to look for the servo one. Oh, what about the music bit, actually? Functions in programming. Page 26 to 38. Let's have some music. Music bit, piezo buzzer plus audio jack. Oh, and they have a little scan me QR code to take us there. That's so cool. And it has a little picture of the music bit as well. Right up there. So let's see, we're going to create a new project. I'm actually going to reuse my old project. Don't tell. I'm just going to delete this. Okay, so the next thing we need to do is go in the input category and pick the on button pressed block. This gives us a new sort of section here to drag actions into that will happen when someone pushes button A. Click the music category and select start melody repeating block. So music. Here we go. On button A pressed. And click on Dotadum and select birthday melody from the drop down list. I'm going to go with blues and see what that is. Click the input category and select button B in the on button pressed block. You have options for button A, button B, and buttons A plus B. And as we saw earlier, these are just hooked up basically directly to the same inputs as the ones on the physical microbit. So anything that happens while you push these happens while you push these and vice versa. So let's go back to the programmer. Click the music category and then click the play tone for beat block. Here we go. Oh! I see. This is actually supposed to be a separate one. So that's on button A pressed, and then this is on button B pressed. So we have two separate actions happening. And you know what I'm going to do? I'm going to have it show something as well, because I like it to show a little heart or whatever. There's some other cool options. Do we have a skull in here or something? Oh, we got a little angry face. We got a ghost. We're going to show a ghost. Okay, so we got the blues. And what are we going to do? Play 5 of these. Huh, they have a duplicate button. If you just right-click. Neat. You can also use your standard copy and paste functionalities. If you don't want to right-click, just hit paste a bunch of times. I think it's a little faster. And they're going to have us program a melody, C, D, F, G, F, for half beat. Okay. Oh, you know what? You should have had us change these half beats before we copied it. But I understand why they did it the way they did. Middle D, middle F. So it kind of looks like you have to know which one is which, but it actually shows you what note you're hovering over underneath the keyboard there. Middle G, and then middle C again for 2.5 beats. Can I choose 2.5 beats? Can I put in something arbitrary? Oh, they're using a little math loop. The purple block is taken from the math category drawer, they say. Fantastic. Oh, not that one. Go away. Drag it to the trash. Math, blank times blank. So this is going to go in here. It's the same shape of, oh, look, they've added little indicators of where you can drag it. That's so cool. So we're going to say 2.5 or any arbitrary number times 1 beat. And that gives us our 2.5 beats. Click on button B of your on-screen simulator. You can test your program using this simulator. And it says, can you guess the song? It also shows you if you were using a regular microbit, how you would hook it up. You'd use alligator clips to pin 0 and ground, and then you'd hook it up either directly to a speaker or to a little tip ring sleeve plug here. It says when you are programming, we got little hot tips down here. I'll show you the kit while we're getting ready to do this. It says, when you are programming, it is advisable to periodically check your code to make sure that you're on the right track. You can use a simulator for that purpose. And then you can continue coding the rest of the song. Oh, I see. It's I will follow you. Follow you, wherever you may go, etc. Cool. Classic. I'm not going to do that whole thing because we're on a schedule. But what I will do is let's take a look at the other languages before. Well, I'm going to download this. I'm going to call it EDU bit 2. Download. Save. And switch over to JavaScript. Look, it's the same thing, but it's written in JavaScript. Magic! And you can see what the logic is in a programming context with text. And then we can switch over to Python. Look at that! Incredible! And you can learn some little basic things about JavaScript versus Python, like how JavaScript likes, well, you know what, there actually aren't any. Well, I thought JavaScript liked semicolons, but apparently I forgot. So it's great for even me to review. Yeah, so we have Python, JavaScript, and then block code, and they're all the same. So you just download a single hex file, and you drag it onto your MicroBit, and I'm going to do that right now, and we're going to take a look at what that looks like. So it's flashing up here, which shows that it is programming. That's just a little LED on the back of the board here. It says, eject MicroBit before turning it off. Yeah, I know. Okay, so button A. Cool. And that's coming out of this sort of low quality buzzer, but I could plug in a speaker over here, like a real one, and it would sound much better. Ooh, look. Oh, it's got a switch to choose between the internal and external speakers. So you'd have to also remember to flip that switch, and that's fine. Either way, I'll give you an audio readout so you can tell if it's your speaker or whatever the problem may be. And let's see. So then we're going to hit button B. Oh, it didn't actually do the last note of it, which is interesting. But I can troubleshoot that later on. These little guys seem to just be hanging out in a sort of vaguely on state. These are labeled A and B, so you can easily... Ha! That's hilarious. It's trying to play both of them at the same time. Okay, we can stop now. Anyway. So, I'm not going to go through all of the examples right now, but hopefully this has given you a taste of the flavor of this board, how cool it is, how many options you have. It's really good. You know, if your classroom can afford however many of these, I think it'd be an amazing way to introduce kids to programming. One of my favorite things about this, as I keep saying, is that you can start out really simple, like really young kids can use this. You don't have to do any wiring. You don't have to do any text programming. Well, there's a little bit of text, but it's mostly drag and drop, right? And then you can grow with it. You can use those 5 big alligator clip things or this kit. And then you can start using the little tiny pins. You can start using JavaScript and Python programming. You can start using all these, like introduce them to buttons, to LEDs, to RGB LEDs, to servos, to DC motors, to potentiometers, to analog versus digital, to sound input and output, to infrared concepts. And it's still got the accelerometer on there. So you could still make something where you sort of like wave this thing around, like wiggle it around, and it would do its thing. Of course, in order to build something like that, it might be a little bit unwieldy to do it with the entire board here, but you don't have to do that because it all snaps apart. I'm not going to do it right now. I'm not going to do it right now. It's a hard decision, but I'm going to save that for later and just play around with this a little bit. I actually have some ideas for using this as a sort of office reminder. Like it can tell me to take a break every 15 minutes. It can tell me if I've done like a Pomodoro productivity technique thing. It can tell you all kinds of stuff on this little readout, as well as the high information density for RGB LEDs, your little stoplight thing. You could be like, okay, well, I'm doing a Pomodoro, it'd be like a green, and then so show that I'm coming up to a rest period, and then give me 5 minutes of chilling out, and then back to 25 minutes of working. Yeah, So many possibilities in one board, and they handle all the power problems for you. You don't have to rip out your fingernails using that JST connector that always bothers me so much. And you still have this reset button available. You still have the charging and programming an LED visible. You still have the access to this display and to these two little buttons. They don't take away anything. They just add a whole bunch of functionality. So hopefully it will come back into stock soon, and you'll be able to buy this thing. I think it's really good for teachers, parents, anyone who's stuck at home with their kids. You want to get your kids into programming. You're new to programming yourself. You want to get into doing hardware? Yeah. They've got links right on the board, Cytron.io, fb.com, facebook.com/CytronTech, support at Cytron.io. Yeah, everything you need to get started, and everything's really nicely labeled. This is a great kit. Thank you, Cytron. And I am happy to wholeheartedly support this thing. This is so cool. Yeah. Thanks for watching. As always, let's see if there's any final questions. Eric says, what about UVC robot? I mean, it doesn't really make sense to build an ultraviolet C. So UVC robot, I assume you mean an ultraviolet C germicidal sanitation robot. You can use UVC light, which is a very high energy, short wavelength frequency of light, to short wavelength, high frequency light spectrum band that has enough energy in it to kill microbes. And so you can use it to sterilize stuff, which is especially relevant now during COVID times. We also have a contest on right now, actually, that is for UVC sterilization robots. Thank you for reminding me of that. As well as tons of other cool ones. Here we are, UV robot design contest. So if you wanted to build a UV robot with this, you could. I'm not sure why you would. In fact, I'm not totally sure that you could anyway, because what I would use for that would probably be a relay, because these things take a lot of power. I actually have a couple of UVC UVC bulbs right here that I'm messing around with. And this one, for example, plugs into an outlet, and you need a switch to control it, to turn it on and off. What I'm probably going to do with this is use a relay to turn it on and off programmatically. But while you can use relays with the MicroBit, they're not included in this kit. What you could do, actually, is use a Grove relay module and figure out how to program that with MicroBit. It's not included in this kit, so that's probably not the best for that. Yeah. Fergus says, microbits are so satisfying and easy to get started with. I've really enjoyed using it in classes. Yes! This looks like it really fixes a bunch of the glaring limitations with the microbit on its own, though. I totally agree. That's what they said in their email. All that stuff about the battery packs, about buzzers and things. I'm losing my train of thought because I've been on for a while. Also, it's kind of the apocalypse here in California. I don't know if you can tell, but the light is really orange because we got wildfires. It's yeah. So let's see. Please don't ask me to check your projects while I'm on a stream. I'm not going to do it right now because I'm streaming. And I'm also not in charge of the contest. But I wish everyone the best of luck in the contests, whichever ones you choose to enter. And have lots of fun with this kit if you get your hands on it. Definitely recommend it. Check out the links in the description of this video for everything that we've talked about. And as always, hack on.